So here's another example of the quadratic formula. So again, I should have written this down to save some time. We know that if we have ax plus ax squared plus bx plus c equals 0, then x, the roots or the zeros of this equation, will be x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So we just have to identify the a, b, and the c. So I will say a equals 5, b equals negative 3, and c equals 2. And then again, I'll draw the shell of my formula. X equals minus something plus or minus the square root of something squared minus 4 times a is c. Those are the somethings there. There's a quick ruler here. All over 2 times a. And then I'll fill those in. So every time I see a b, I'll put a negative 3. Every time I see an a, I'll put a 5. And every time I see a c, I put a 2. Okay? And now we just evaluate that. A negative times a negative is a positive, so we've got 3 plus or minus the square root. Negative 3 squared is 9. 5 times 2 is 10. 4 times 10 is 40. All over 10. See, that's what happens when I don't use a ruler, see? So listen to my old little creed there. That's a big old mess. There we go. Okay. Sorry about that. And then that's going to equal 3 plus or minus the square root of negative 31. All over 10. Now, remember when we have the square root, we talked about this when we did complex numbers, we don't like the square root of a negative number. In other words, we remember we always got to take out the i's. Just like when you're peeling potatoes, first thing you do is take out the i's. So x equals 3 plus or minus, and I take that square root of negative 1 out as I, and I have I times the square root of 31 all over 10. I got rid of that square root of a negative number. We don't like that. But we have a complex number here. And usually when we have a complex number, we like to write it in standard form. So that's going to be 3 over 10. We'll break it up into 2 fractions. This is the real part they call standard form. Plus or minus the square root of 31 over 10. This is what they call the imaginary part because it's times I. Now we do have 2 roots here. 3 over 10 plus the square root of 31 over 10i. And you could calculate that out if you needed a number. And 3 over 10 minus the square root of 31 over 10i. So let's see if we can graph this. Now we have our zeros. So I'll draw a graph, a little sketch over here. And we'll see if we can find our zeros. And here's the thing, we don't have any zeros because they're imaginary, they're complex numbers which don't appear on this graph because this graph is only real numbers. This graph only does real numbers. This is a real axis, real numbers x and real numbers y. So we can't really graph this in the real number plane. Well, it's a parabola. We said these are parabolas, so what's it going to look like? Well, we know since this is positive, it's shaped like a U, but since it doesn't have any real zeros, it's going to be something, it could go something like this or like this. I'm not too exactly sure what it's going to look like, but it's going to look like something like this. And we really can't tell unless we find the vertex. And we could find the vertex. I don't really want to do that right now, but we could find the vertex by using the negative b all over 2a to find the x value so we know where this is. And then we could substitute that back in and find the y value. That would be a little bit of work, but we could do that, and we would find out that it's something like this. Okay. Now I do have a graphing calculator, so I can kind of cheat and show you what it looks like to verify that. So I'll get this out and show you. I know you don't have graphing calculators, but let's see how close my guess was. So I'll put this under here. I guess you can see that. And what we'll do is we'll turn it on and go to y equals. I got some stuff there. I got to clear this out. And then I'll put 5x squared. 5x squared negative 3x plus 2. Oops. And I'll just graph that. I'll just go to 6 and graph that. And there it is. So you can see how it looks. That wasn't too bad off, was I? It's a little skinnier. I'll zoom in a little bit. And there it is. So you can see it doesn't touch the axis. I can change the window here by going up a little bit here. And you'll learn how to do this a little bit later. And that's what it looks like. So it doesn't touch the axis. And the vertex would be right over here. So I guess you could see that. So I had kind of the idea. So that's what happens when we have complex or non-real roots. We have no real roots. We have two complex roots. And that's because we had a negative under the radical here. Okay? So does everybody see that? I hope you understand that. I hope everybody gets that.